We continue with our revisions, grade 12 for the June 2002 paper 1. Question number 2 falls under sequences. So here is the question. Maybe you don't have the question paper. So this is the question. So I will remove the projection so that we can have it becomes more visible when we do the workings. Two point one. We are given the sequence half, 5, 1 over 4, 9, 1 over 8, 18, and it continues. So 2.1, if the pattern continues right down the next two terms. So if we look at this pattern, we should be able to see very quickly that it is a 2-in-1. We have a pattern half, 1 over 8, sorry, 1 over 4, 1 over 8, and then continues. And then we have 5, 9, 18. Continues also. So on this one, we can see that each term is being multiplied by 1 over 2 to get the next term. So it means we are going to multiply 1 over 8 times 1 over 2, and that will give us 1 over 16. And this one is an addition of 4 to get the next term. So the next term will be 13 plus 4, that will give us 17. So the next two terms here is we'll have 1 over 16 and 17. That is 2.1.1. 2.1.2, calculate the sum of the first 250 terms of the above sequence. Now, we know that when it comes to the sum, we are basically talking about the geometric series and the arithmetic series. Nothing besides that. So, of the two sequences we have, half, 1 over 4, 1 over 8, it is a geometric progression, and 5, 9, 13, it is an arithmetic progression. So it means that we need to find the sum of the terms in this progression, and if the question is saying 250 terms, 250 is an even number, which means that we are going to have half of them coming from the geometric and half of them coming from the arithmetic. So that means half of 250 is 125. So 125 are coming from the geometric series and 125 are coming from the arithmetic series. So for the geometric series, we want to get the components that we will substitute into the formula. So we need R, that is T2 divided by T1, we can take that, which is 1 over 4 divided by 1 over 2, which will give us 1 over 2. Our N is equal to 125, and then the formula that we will use, sum of n terms is equal to A into 1 minus R to the power n divided by 1 minus R. We choose this because our R is less than 1. So we do the substitution. Our A is half into 1 minus our r is half raised to the power 125 divided by 1 minus half. And then substitute this into the formula, into the calculator to get the answer, which will be which will be 1. And then coming to the arithmetic series, 5 plus 9 plus 13 plus until we get to 125 terms. We know that the sum is equal to n over 2 into 2a plus n minus 1 by d. So we need our a is equal to 5, our d is 4, and then our n is 125. So this will be 125 over 2 into 2 by 5 plus 125 minus 1 by 4. And if we simplify this, we get 31,625. So we are saying, therefore, sum of 250 terms will be 31,625 plus 1, which will give us 31,626. So that is 2.1.2. Then 2.1.3, find the 80th term of the sequence. Alright, let's not forget that the 80th term of the sequence, it is a term in this sequence where we have two sequences in one. So we need to determine which sequence will give us the 40th term. So if we check the geometric progression is occupying the odd positions 1, 3, 5, and so forth. And then the even positions are taken by the arithmetic terms. That is the second, the fourth, the sixth, going like that. That means the 80th position will be taken by the arithmetic. So it means it's a term from the arithmetic progression. And which term? Because we are saying of the 80 terms, half of the terms, that is 40, are from the geometric progression, and then the other half, the other 40 terms are from here. So it means term number 80 will be term number 40 in the arithmetic progression. So we are saying now we need to find the general term for the arithmetic so that we can find term number 40, which will be term number 80 in the combined sequence. So Tn is equal to a plus n minus 1 by d, which is 5 plus n minus 1 by 4. If we decide to simplify, 5 plus 4n minus 4, which will give us 1 plus 4n. That is our Tn. So we are saying term number 80 is equal to term number 40, which is equal to 1 plus 4 by 40, which is 1 plus 160, which is 161. So term number 80 is 161. All right, moving on to the last part of the question, that is 2.2. If the general term of a quadratic sequence is 117, y49, and it progresses in that pattern. And we are also given Tn, which is 2n squared plus bn plus c. And the terms is 1x, 17y, 49. So the question is find the values of x and y. So it means we need now to create equations from which you solve to find the values of x and y. But let's not be blind. We can see what we are given. We are given a. So it means we have something that we can work from. So for the quadratic, we know that we have the first difference. So in this case, it will be x minus 1, 17 minus x, y minus 17, 49 minus y. And then the second difference, it's 17 minus x minus, please, you are subtracting an expression, so put it in brackets. I've seen learners making this error. They just say minus. They don't put brackets and say x minus 1. And that's the end of it. Then here we have y minus 17 minus x. And then we have 49 minus y minus 17. Now, simplifying this, it will be 17 minus x plus 1, which is 17 plus 1, that's 18 minus 2x. If we decide to simplify this, it's y minus 17 plus x, that is y plus x minus 34. If we decide to simplify this, that will be 49 minus y plus 17, which will give us 49 plus 17, that's 6 minus 2y. So what we know is that the second difference is 2a, and our a is equal to 2. That means our a is 2, so this will be 2 by 2. That will give us 4. So the second difference is actually equal to 4. So we can take this, therefore 18 minus 2x is equal to 4. So we can take the negative 2x and then we bring the 4 this side. That is 18 minus 4 is equal to x. That is 14 is equal to x. Therefore, x is equal to 7. And we can also, since this one is having x and y, it will take time to get y. So it's better we can use 66 minus 2y should be 4 also. That is 66 minus 4 is equal to y, which is 62 is equal to y. Dividing by 2, that is 31 is equal to y. So this is how we can solve. Of course, there will be other methods. We can equate this and this, we can equate this and this, and then we solve simultaneously. But at times you need methods that are quick to get to the solution. Alright, that is 2.2, and that is the last question to give you the 16 marks. Alright, let's take a break and then we will resume on question 3.